Hello, this is Beth Dixon from Walter State Community College, and you can reach me at beth.dixon@ws.edu. And if this is not the spring of 2020, you can reach me in the Math Behavioral Social Science building at the Morristown campus in room 222. If it is still the spring of 2020, you know what's going on, and I may not be in campus yet. So we are working through the Math 0030, I don't know why it says that, 0030 Final Exam Review, and we are up to page 9. Did I just finish page 7? Page 8, yes, I have finished both page 7 and 8. I am all the way up to page 9 in this here, and we're on problem number 29, and we're asked to complete the following table. And the completing the following table is all about interval notation, inequality notation, and graphing on the number line. As I do these problems, I always go through the interval notation through the number line to inequality notation through the number line to interval notation. I never go from interval notation to inequality notation or from inequality notation to interval notation without using the number line. The number line is my key to get to interval notation, and my interval notation is immediately transferred to the number line before I try to go to inequality notation. So the number line, or the picture, is the key. It's that old phrase, a picture is worth 1,000 words, and I really mean it here, because I can show you in a picture a lot more than I can show you or tell you in words. So let's start with this first line, this first row, and it says the interval notation is from, I didn't set my timer. I like to set a timer just to make sure that these are, so I'm sure what the length of these videos are. So let me set my timer. And then we've got from negative infinity to 2, both of those with parentheses. Remember that your parentheses are always used with your negative infinity and positive infinity, because we can never reach those numbers. Those are always out of reach. We cannot close those intervals. So those are always what we call our open intervals. And then those are always with their less than and greater than, also have open intervals. Our closed intervals are our brackets, and they go with less than or equal to and greater than or equal to, and they go together. Those are the ones that include the endpoints. They actually don't, an open interval, you go up, you get closer, you get closer, you get closer, you get closer, but you never actually touch. If it goes up and includes that endpoint, but nothing beyond that endpoint, it includes that place, but nothing beyond, that's an closed interval. It goes to that point, it closes it down. An open interval would be like, it is less than 3, so it can be 2.9, 2.99, 2.999, 2.9999999, and on. So it's open in that there can be infinitely many numbers, but it doesn't close that interval. A closed interval then closes at 3, or at least that's how I think of it. Whether it's as mathematically accurate as it needs to be, I don't know. Doesn't matter. So in this case, we have an open interval on both sides. So if I draw a number line, so I'm just going to draw my number line, probably would have been better if it had a straight edge, but we'll do that there. And I'm going to put a 2 on it, and we don't have to be real accurate. I like to put my 0 on mine so that I know where the center is, and then my 2 should be on the positive end. And then in this case, my negative infinity is always to the left. My positive infinity is always to the right. And for emphasis, I'm going to try something a little bit different here. I'm going to try this to see if they show up any better. and for emphasis, I'm going to say that this interval starts at 2, and it will be an open interval, so it will be a circle, and then it will shade all the way down, continuing to -2, negative infinity. And in this case, I really probably should have started at negative infinity and shaded up here and then to 2, because I read this from left to right. And I'm sorry, you have my mouse in the middle of the picture and you can't see. So we have negative infinity to 2, and then it's an open circle here. And this one just continues on since we can't do this, so I'll just draw an arrow in that direction. So what does this translate? Well, the values are at 2. We don't use negative infinity, so I have an x for my variable, and the values of x, are they less than or greater than? Well, if we're going down, these are the values less than. And if my x is on the left, it always points to the direction it's shaded. So it will point to the left, since this is shaded to the left. So x is less than 2. And it shouldn't have an equal, because the parentheses go with the less than and the greater than without the equals. If it needs an equals, it will be the brackets. Okay, in this one right here, we're going to go this way first and get the inequality. It starts at -5 with a dot. A dot, open circles go here. I don't know why I drew 2, but open circles go there, and closed circles come here. So we're going to look at our open circle here, and, our closed circle here, and then it shades and goes in this direction. In this case, negative infinity is down here, and positive infinity is here. And so what we have then would be our x. In this case, it points to the right. So it will point to the right. That'll be our greater than sign. And it will be greater than or equal to, because it has a closed circle. Therefore, it's a closed interval, which will include that point. It can equal -5, and it'll be -5. And so that's the inequality notation. And looking at the graph, it shades and points to positive infinity. When we write our interval notation, we always go from left to right. The smallest number are to the left to the largest number on the right. So this one will start at -5, and because it's a dot, it will include it, so it will be a bracket, comma. Now, what's the largest number? Well, it just keeps going, so it's headed toward that positive infinity. And then infinity, no matter what, gets a parentheses. We can't touch this. Remember, MC Hammer, can't touch this. Okay, now, this right here is a special case. This says the x is between -1 and 5. It says that x is greater than -1, but less than -5. -1 is less than x, less than or equal to 5. Basically, if I looked at it this way and read it backwards, it's saying x is greater than -1. The x's are larger than -1. Remember, it opens to the larger number. It opens to the larger number. So it's opening to the x. The x is greater than -1. So when I look at my number line, I want a -1 and a 5. And I know I'm going to have a dot above 5 because it has an equals to, a circle above 1 because it doesn't have an equals to, and my x's range in value between those two values. And so negative infinities down here, positive infinities up here, but those two won't come into use because I stop between -1 and 5. So my -1 would be my smaller number, 5 would be my larger number. -1 has an open circle, so it would need a parentheses. 5 has a closed circle, so it would get a bracket. My next one has the same thing going on, -2 and 4 with a bracket on the -2 and a parentheses on the 4. So the first thing I want to do, I do not go over here to the inequality. The first thing I'm going to do is make my graph, draw my number line. I'm going to write the numbers -2 and 4. Again, notice I'm not doing elaborate number lines, just the bare minimum that I need. And then above the -2, because there is a bracket, would get a dot. Above the 4, because there's a parentheses, would get an open circle. And it's saying that my range of values falls between those. The smallest is -2, the largest is 4. So I'm going to draw in between those. Notice how it looks just like the one above it. So that means my answer here will look the same as well. X, and then notice that it always goes from the smallest to the largest, so it's a less than sign in both directions, so that the smallest number is here because it's less than both of those, and my largest number goes here because it's greater than all of those. It always goes from the smallest to the largest, with the X's being between those two values. So I know that the -2 will go here and the 4 will go here, but I've missed something. I hope you've caught it. And that is that the -2 is included in the endpoint. It was a closed circle. It had a bracket. So I need to put an equal sign on that -2 with the part that the X and the -2, so that it shows that the -2 is equal. Notice the 4 does not have the equal because it's an open circle. Notice the difference here. The 5 was included, so it got the equal. Here the -2 is included, so it gets the equal. Okay, on the next one we have X is less than 3. So that would be here. We need a 3. And then we have X is less than 3, so it'd be an open circle. And since X is less than, it will shade in the direction that it points. So we go in this direction. Now this only works if the X is on the left. If your X is on the right, it does not work. You can shade to the way that it points only if the X is on the left. If the X is on the right, it does not work. That's why in solving inequalities, we tend to write the X on the left. It helps us then shade. And I'm real dexterous, which means I don't know my lefts from my right. I do know my less than from my greater than. Now, why is that? One, because it's left and right that I have difficulty with, but more importantly, because I know where my negatives are. My negatives are on this hand. My positives are on this hand. On a number line, the smaller numbers are this direction, and my larger numbers are on this direction. Now, sometimes I get it confused when I say left and right, but your smaller numbers are to the left, and your larger numbers are to the right. So as you look at this in the shades, where are the values less than 3 would be to the left, and that's which way you shade. Now, as we write this, remember again, you've got negative infinity to this direction and positive infinity to this direction. I didn't even write that here because it wasn't needed, but I'm going to write it again here because it will be needed. We want to write the smallest number, then the larger number. The smallest number, since this keeps going and going, has to be the negative infinity. The largest number then is the 3. The negative infinity always gets the parentheses, and the 3 has an open circle, so it gets a parentheses. We've moved right along and we're ready for the last one. It's also one of these in-betweens, like this one and this one. So when we do that, we know we're going to have an X and an in between. This one has a solid dot on this side, so I'm going to go on and put the equals there, an open circle here, so that does not get an equals, and the smallest number is a 1 that gets the equals and the dot, and the 7 does not, it gets an open circle. Then that leaves us for our interval notation. Had a brain fade there, sorry. And then we go from 1 to 7. The 1 gets the bracket and the 7 gets the parentheses because the 1 has the dot. It's the included point, and the 7 gets the up to but not touching point, so it gets the parentheses. Okay, now let's switch gears and go to number 30. The polynomial 0.1x squared plus 4.4x plus 10.7 can be used to approximate the percent of the population who have cell phones, where x is the number of years after 1995. Approximate the percent of the population that have phones in 2010. Okay, so we have the number of years after 1995, and we want to approximate the percent in 2010. So 2010 minus 1995 would give us our x. So we'll turn my calculator on. Charging is recommended. Oh dear, my battery is going dead. So I'm going to hope that it lasts through this video. 2010 minus 1995 is 15. And so that would be my x. And so what I'm going to do is take 0.1x squared plus 4.4x plus 10.7, which is my equation, and substitute in 15. 0.1 15 squared plus 4.4 times 15 plus 10.7. Folks, that's all the work you need to show. At that point, you can then go 0.1 15 squared plus 4.4 times 15 plus 10.7. Enter on your calculator. And oh wow, that's 100.7, and that would be 100.7% of the population. That just doesn't seem right, so maybe I typed in something wrong. I typed in 4.5. It's 4.4, so let me do that again. Notice I hit second enter. Let me do that again. I hit second enter and pulled it up. That time I just went up. Sometimes you can just go up on my calculator and hit it. And I hit second enter the first time, and then I arrowed back and hit a 4 and then hit enter. That's much better. Now, how did I know my first answer was wrong? Because you can't have more than 100% of the population owning a cell phone. If 100% of the population owns a cell phone, that means everybody does. So 100.7% is more than everybody owns a cell phone. Well, I guess you could say some people own 2, but that just doesn't make sense. It wasn't a reasonable answer. But 99.2% of the population owning a cell phone in a certain country would make sense. And that would mean almost everybody does. And in this case, I would have to say it would have to be adults, because even though we're getting younger and younger children, I don't imagine babies own cell phones. Okay, let's look at problem number 31. Levon can make a weekly profit of money after he has paid costs from his house cleaning business according to this formula. So they give us a formula where Y is the profit in dollars and X is the number of hours on the job. Complete the following table. Now we can use the calculator to do this, or we can just crunch out the numbers. The formula is 10.25 times the X. Well, the first X is 10, so I'm going to plug 10 in. minus his cost, which must be $82. So if he does 10 hours of work, he makes $20.50. Now, why did I put 50? Because it's money. So I like to think of it as money. So I'm going to put $20.50. Now I need to put 20 in next. I can retype it. If you want to do that, that's fine. I'm going to do that what I was showing you earlier, which is to hit second and then enter. Notice it pops up that last thing I did, and I'm going to arrow back, and where it says 10, I'm going to type 20 and then press enter, and that gives me 123, so $123, and then hit second enter, and that brings up that previous one, and change that 20 into 30, and that would be $225.50. And again, it would be right if you just put 0.5 and then do second enter and change that 30 into 40, which would be $328. That's all that it's asking you to do, is to fill in that chart. And that's showing your work. You don't need to, you could show, if you wanted to show your work, you could go 10.25 times 40 minus 82 equals 328. That would be all the work you would need to show. A target heart rate measured in beats per minute for moderate exercise can be approximated by the function T of x equals 150 minus 0.7x, where the x is the person's age. Evaluate T of 40. So in this case, T of 40 would be T of 40 equals, and that just means we're going to plug in 40 for x. And again, we'll just use the calculator to crunch that. 150 minus 0.7 times 40, and that gives us 122. So now it wants to interpret. Anytime we see the words interpret, we need to use words. So we need to write a sentence, and we're going to use the words in the problem as part of our sentence. Now, the first thing we want to know is we've got T of 40 equals 122. And if we have 40, that's our X. So X is the person's age. So I'm going to start with that. When the person is 40 years old, then what does the T tells us? The target heart rate, and I'm just copying exactly what's up here, the target heart rate, and I'm going to skip measured in heartbeats per minute, for moderate exercise can, or should be, because it can be approximated by here. So for moderate exercise should be 122, and this is in beats per minute, so that would be beats per minute. So all I'm saying is that, okay, so if the X is 40, that means the person's age. When the person is 40 years old, what am I getting? Well, the function says T is the target heart rate for moderate exercise should be, or is, 122 beats per minute. So if you're 40 years old, your target should be 122. So I'm going to stop here for page 9. So that completes page 9. And again, if you need to contact me, you can reach me at beth.dixon@ws.edu. Or if it's not spring of 2020, you can find me in the Math Behavioral Social Science building on the Morristown main campus at Walter State in room 222. Have a good day.